everyone. This time we go to the algebra of the trigonometry. We call this trigonometry identity. So there's many identities. That's just a short overview. 1, 2, 3, 4. There are four big category of the identity of trigonometry. Let's introduce one by one. Okay. First is reciprocal identity. Reciprocal, of course, is which means like it's like change the position, right? So here we have cosecant data equals to 1 over sine data, and the second is cosine data is equal to 1 over secant data, right? And tangent data equals to 1 over cotangent data. This is quite easy to understand, right? Because why? Because sine is equal sine data equals to what? Sine data equals to y over r. Am I right? So cosecant is what? Is r over y. So definitely cosecant is 1 over sine. And cosine data equals to x over r. R is radius. And if you reverse them, r over x is what? A secant, right? R over x. Let's see one. Tangent. Tangent is what? Tangent data equals to y over x, right? So definitely is same as the reverse x divided by y is cotangent. Remember this. All those identities can calculate by this way, okay? So another identity is quotient identity. Quotient identity is a divide, right? So tangent equals to sine over cosine. Cotangent is to cosine over sine. This, if you know tangent, so definitely you know cotangent, because cotangent is just reverse, so definitely it's reverse. So y tangent is equal to sine divided by cosine. So let's see, here we already know tangent is y over r, right? So let's just do a little proof. Tangent data equals to y over r. So y over r. Am I right? Am I right? So what is the sine data over cosine data? Sine data is sorry, y over x. Y over x. Okay. So this is equals to what? Y over r then divided by x over r. Am I right? Am I right? Am I right? Yeah. If this is right, then y over r is sine data, and x over r is cosine data. So you already approved that. Then is Pythagorean identity. These have three. Sine data plus cosine data equals to 1. This one you have to remember. Sine data plus cosine data equals to 1. And the second is tangent data square plus 1 equals to secant data square. And the third one is cosecant data square equals to 1 plus cotangent data square. Okay, remember this. But how to prove that? First, let's compare with let's see the first one. Sine data square plus cosine data. Sine data equals to y over r, then square. Cosine data is x over r square equals to what? Y square plus x square r square. Is this equals to 1? Remember, we are talking about when study about angle. Just here is data, okay? And this is a point P. So what's the what's the, okay, normally we draw a line here. So this is x, right? This is a y. And this radius is r, right? So think, since this is a right triangle, so x squared plus y squared is equal to what? R squared. And r here is equals to 1 unit. So y squared plus x squared equals to 1. Am I right? Right? So you can understand why is this called Pythagorean identities. Pythagorean identities also Pythagorean theory is based on right triangle x square, two side the square the summation of the square of each side equals to the hypotenuse side square, right? How about this one? Tangent, tangent plus 1. Tangent, what is tangent? Tangent is y divided by x square plus 1. See, what is second? Second is cosine, reverse. Cosine is what? Cosine is x over r. So here is r over x square, right? So square here. So r equals to x square plus y square over x square. Am I right? Left equals to right, right? So yeah. So the same way we can get the third one. Let's see another identity, even older identity. This one is mm, I'm not sure if we can prove by this way. Okay. So first, because this is more easy to identify just by the graph. This is data. Okay. This P, this X, Y, R. Okay. Science negative data. Science negative data is here. Same angle, but it's go to the right. Another side, so it's negative data. So here it's another P. So okay. P pi. Okay. So we can see here what's the difference. X axis will not change, right? Only Y will change, right? R definitely will not change, right? R, because R is always will be positive, right? So since only changes Y, and Y from the positive side go to the negative side, so definitely is negative, right? The result will not change. The only difference is a sign. So if negative, you can draw negative out. The cosine here is, that's why I call even and order. So this is even. If negative is same as positive, why? Cosine is equal to what? X over r. Look at here. X will never change, always here. X over r will never change whenever your angle is go up and go down. So definitely we approve this. How about tangent? Tangent is same as order, right? Order identity. So tangent is what? X y divided by x. Y divided by x. Y divided by x. So same. Here the only difference is y. One is positive, one is negative, but the same kind of the uh, number, right? So definite is order, right? So this is the four criteria, four standard of identity of the trigonometric. So remember this, they have a lot of algebra calculation based on this. Okay, I have two examples we give you. The first example will be if sine theta is equal to 1 over square root of 2, find the cosine, tangent, cosecant. Yeah, okay. So first, if we know sine, so based on the I always forget how to call that Pythagorean identity, right? So we can find the cosine, right? Because cosine theta square is equals to 1 minus sine square, right? So 1 minus square 2 over square, right? Right. So cosine is what? So 1 over square root is 1/2. Then when they get is 1/2, and then square root again. So same. Cosine same as sine, right? So if you know sine, cosine, so of course you know tangent, right? Tangent is sine divided cosine. Since they're same, the tangent is 1. So since cotangent is just reverse of tangent, so cotangent theta also equals to 1. Since you know cosine, so you know secant theta because it's a reverse, square root of 2, right? Same, since you know sine, so you know what? Cosecant theta equals to square root of 2, right? So now you understand. If we know trigonometric is any one of them, they have 6. You can find the rest of them. Okay. So the next example is I ask you to simplify. So how this looks like? How can they simplify like this one? Finally, what this looks like? They have different way to simplify this. Okay. I use a comparing it to me is a little stupid way. Okay. Let's see if I can. If I cannot, I will change to the easy way. Okay. So tangent equals to what? Sine over cosine. This is right? So 1 plus cosecant. Cosecant is what? Is 1 over what? Sine. Am I right? So here, let's see. So tangent is sine theta over cosine theta. Second is 1 over what? Cosine theta. Am I right? So let's simplify on both sides. Nominator side. So here, this one will be cosine theta sine theta. Am I right? So this side will be what? No, that's nothing changed. Sine theta and what? This should be the sine theta plus 1. Am I right? Yeah. And then below, this is a cosine. Wait, this is a second cosine. Oh, so they have same denominator. Okay, so that's easy. So sine theta plus 1, right? How to solve this is this times this times this. Am I right? So what's the denominator? What's the denominator? So sine theta cosine theta and the sine theta plus 1. Am I right? And the below is cosine theta sine theta and the sine theta plus 1. Oh my god, they're same. So happy for that, right? So equals to 1. So you see that it's very interesting to calculate like this way. You also can calculate use the exact form like tangent equals to what? Equals to y over r. You can use this way to simplify them. Okay. So thank you very much. Today we totally introduced 4 trigonometric identities. Please remember them, and they will be very useful for you to calculate different kind of the algebra issue of the trigonometry. Okay, thank you very much to join this session. Bye bye.